Zoom recording. Let me do a screen share. And again, the reason why I'm waiting until the end is because in an exam, when you get a question about design patterns, you're not going to be told if it's even behavior or create. You have to decide on the main category, the major category, before even deciding on the subcategory. Okay. We might have not had that situation with the quizzes, but then again, at the quizzes, you were only deciding between two different design patterns anyways. I'm pretty sure the singleton was quite out of the question anyways. All right, so in the factory design pattern, we have going to be covering 4 design patterns: the iterator, observer, state, and chain of responsibility. Very, very interesting design patterns, very, very important ones. We'll begin with the iterator. The purpose of it is to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. Am I missing something here? Can you tell us a guide on how to differentiate between all 3? Yeah, I'm coming to that. We'll do that, Yasham, after I finish behavioral design patterns, because it's not going to make sense because we haven't started behavior design pattern. But structural design patterns and behavior design patterns are not part of the midterm, so we're not going to worry about this right now. All you have to worry about at the midterm is to be able to figure out if it's abstract or abstract factor or just regular factor. Okay. Taban singleton is quite obvious on its own. It's quite of a completely different flavor here. All right. What we're going to do is we're going to encapsulate the iteration in a class pointing in effect to an element of the aggregate. Now, I know all this doesn't make any sense until, let me step out here for a second. I'm going to pull up the whiteboard again. Make sure you guys are seeing the whiteboard. Right. What the whole purpose of the iterator design pattern is. I got an aggregate here, okay? Some collection of objects, okay? I'm going to put down 4 objects. One is called A, one is called B, one is called C, and one is called D, okay? Now, I want to be able to iterate through them, maybe in ascending order, or maybe in descending order, or maybe in whatever order that I want. But what I don't want is, I don't want to permanently restructure these objects. I want to leave them as a bag of objects that are not sorted anyways, okay? I don't want to be messing with the actual origins, the source of the data, okay? Now, if I want to be able to iterate, in other words, go through the different objects in my bag in a particular order, that's a problem left up to me, okay? I don't have to bring and shove these objects in a particular order in order to iterate through them in a particular order that I want, in a particular sequence that I want. So what I want to do is, what I'm going to do is, I'm going to create the orders that I want as empty arrays as such, okay? Let's just think of it as such, okay? Got 1, 2, 3, 4, okay? One of us is going to be called ascending. The other one is going to be called descending. And in the first one, I'm going to put A, B, C, D. The other one, I'm going to put D, C, B, A. Really, what I'm actually putting is not any of those, okay? What I'm actually putting is a reference for A, a reference for B, a reference for C, and a reference for D over here, okay? In the descending array, I'm going to put a reference for the D at the top. I'm going to put a reference for the C in the second one, a reference for the B in the third, and finally a reference for the A in the last one, okay? I'm going to create over here an iterator object, okay? But a specific one, a descending iterator, or ascending iterator, okay? And then the iterator just basically goes and grabs that array, goes from top to bottom, okay, from array.size or .length, and all the way to the bottom, get next, get next, get next, get next, until we're done with that array, which means I would have iterated through the ones that I care about, okay? Now, let's take the flexibility even to more extreme, huh? Let's just say actually we have this situation. I got A, I got B, I got AA, and I got BB. Okay, I can decide to have multiple. Sorry, let's just not AA, BB. Let's just call it CC and DD. Okay, can have multiple sorts. Okay, one of them is A, B, C, C, so it's ascending. One of them is just they call it double. You know, double letters. Okay, and those ones I just want to have CC and DD. Okay, so I've created a list, but it's actually a sub list of a subset of the objects that exist in that bag. I can do anything I want. Okay, if I really, really actually wanted to, I could have also done something as such. Okay, I would have put in B followed by DD followed by C followed by A. خلاص مزاجي ده بكيفي. Okay, this is the one that I want. Fine, but doesn't matter which and how many ones we create. Okay, all they're doing is they're having references of the original objects. Okay, and what we're doing is we're not messing at all with the main structure, which is just happens to be 4 objects that are hanging out together. Okay, that weren't in an array to begin with. Okay, and we're just having references for those objects, and then each one of those is going to have an iterator on its own. So this is iterator 1. Okay, oops, 1. This is iterator 2. This is iterator 3. This is iterator 4, and so on. Okay, right? And like I said, I'm going to repeat this again. All the while, despite having different orders and sequences, okay, the main structure over here remains untouched, permanently or non-permanently. Okay, the references that I'm having from those arrays to these objects, the objects themselves, object A and object B and object C, never were really even aware that those references were made to begin with. Okay, you want me, I don't want you. This is the perspective of the actual product objects A, B, C, C, and DD. Okay, so any questions about this, guys, before we move on to the code level? Gonna look at a code level example here, but before I do that, I just want to see if there's any questions. Is that clear what I was just saying? People at home? Okay. All right, so if it's unclear, just make sure you do send me a text message on the chat. Okay, so let's go back here to the actual slides. Okay. All right, so got an aggregate object, okay, that I've created. For example, I got videos, and you can tell like how old this example is. But I got videos. One way I wanna, iterate through them is through alphabetical order. Another way is I wanna maybe iterate through them, and not through the entire list of videos, but just the ones that are on loan. Okay, I can do whatever I want. Okay, but I will create the different iterators: iterator 1, iterator 2, iterator 3, without actually having to change or put the actual videos in any particular structure per se. Every iterator will have 4 standard functions. Okay, it's not really the interesting part of the design pattern, but basically one is to point to the first element in that array. All right, and then you got increment. It moves from one element to the next. All right, and then the get current element, the last one, grabs that object that is pointing to and does something with it. And the is done is to put it in a for loop to make sure that we move on to the next object, to the next object, to the next object, and so on. So this is really kind of like a fancy way of providing support for the for loop. Okay, so the for loop, instead of saying going I equals 0, is going to go set to first. Okay, and when it says while I is smaller than array.length, it's actually saying is done. Okay, the I++ is the increment. And inside the for loop, when it's actually wanting to use what the I index is referring to, is using the function get current element, and then you get the element, you get the object, you do whatever the heck you want with that object. Okay? Right, so as you can see, this is the for loop set to first. If it's done, if it's not done, keep on going. And then at the end, increment. And for every single loop, make sure you get the current element that I'm pointing to and do whatever desired operation that I want to do with it. Okay. All right, so here it is. This is the class diagram for it. Okay, I got the aggregates. All right, I can list them in different ways. So this over here means the different aggregates. These are the different arrays that I want to put in a certain way. So one was A, B, C, and the other one was C, B, A, the opposite. Okay, one of them was just a sublist, A, B, not the entire thing. Okay, and each one of those in the iterator, we're going to have multiple iterators. This is iterator 1, this is iterator 2, this is iterator 3. Iterator 1 is going to be pointing to this one. Iterator 2 is going to be pointing to that one. Iterator 3 is going to be pointing to this one over here. Okay. And every time it's pointing to that array, at some point, it actually grabs an element from it. So here I got, this is my concrete aggregate. My eye is pointing over here. So I pull out the object. Okay. That will be my aggregate element. And I give it up to the client to whatever it wants. For example, it wants to print its name, it wants to add it to some, do some mathematical function with it. It's really up to the client to do what it is they want, it pleases with it. Okay. Okay. So here's an example. I got a client, right? So I got a whole bunch of employees, tellers, and supervisors. Okay. So these are my iterators. Okay. One of them, I'm going to iterate through my entire organizational chart based on the type of service that is being provided. Okay. So tellers first, then supervisors. The other one is based on the seniority level. Okay. It's based on the seniority level, meaning I have a whole bunch of T object tellers and a whole bunch of supervisor object S's. Okay. For the service iterator, I'm going to create an aggregate, and it's going to be based on the type. So the T's first, followed by the S's. The other one is based on seniority. So each one of those has a seniority, 5, 2, or 3, 2, and so on. And then I start to list them up as such. So this is the one with the most seniority, followed by was an S, followed by another S, followed by a T, followed by another S, and so on. Okay. And each one of those, this is the iterator that goes through the seniority. This is the iterator that points to the aggregate that is by type of service. Okay, so let's go now to the code level. Okay, first I'm defining the something called an aggregate, and every time I create an aggregate, in other words, an array, to hold my objects of interest in it, that array has to come attached with it some sort of an iterator. Okay, that I. Okay, by the way, the reason actually the for loops always keep saying for I equals 0 and I equals blah, blah, blah. That letter I actually comes from the word iterator. It's just because iterating, it's not a coincidence. Okay, so this comes as one set. Okay, the aggregate along with its iterator. Okay, they come together. Okay, it's almost like buying a PlayStation. You get the console and then get the what's it called, the joystick thing. What's it called? What do you call it, guys? The thing that with you play with your hand. You want to play? Tell me nobody here plays with PlayStation. Nobody's got a PlayStation at home. What was it? Controller. Yes, thank you, Shem. Okay, so they come together. Okay, so you got the console with the controller. Okay, you don't get the console without a controller. You don't get the controller without a console. All right. Actually, you can actually get a controller without a console, but that's not really the point here. Fine. I'm going to create one concrete aggregate. Okay, so you'll see I got an array, started off empty. Okay, and I'm going to create an iterator I. Now notice this. the concrete aggregate is given itself as a reference to the iterator that is created. You see this? Huh? It's using the word this in the constructor of the iterator. Okay, so again, let's repeat this over here. All right, the aggregate concrete comes in. First thing it says, I'm gonna have an array. Okay, I'm gonna be, one of my elements is an array. Okay, and this is my array. It's called items. Okay, and then this is my concrete aggregate. Okay, and then it produces an iterator. Okay, and then it gives itself as a reference to the iterator that it itself created, so that later on it can go in here and find the items and start going through it. Okay, it's got some sort of a function to get the items count. It's not really the interesting part over here. Some setters and getters, again, not really the interesting part of it. But the point is, it's going to be pointing at it. It's going to be doing something with it. What is that something is not really of interest to it, but it's pointing at it in a certain order, and then it's going to iterate through it. Okay, we need to be able to get a reference to the aggregate to iterate through it. All right. Now I got the general iterator class, got the 4 main functions that I gotta have. First, next, is done, and current item. Okay, here's my concrete iterator. Now remember, 2 slides ago, we said we gotta be giving this ourselves. The concrete aggregate is given itself as a reference to the concrete iterator that is actually creating itself. Okay, so where is it? Okay, here we go. It's right over here. Okay, it's given itself. And so the iterator now is pointing to that aggregate. Okay? And then next off, we got the implementation for the first, next. It's not really the most important, current item, and is done. Not really the biggest deal here. Okay. This is kind of like a standard to us, a standard iterator for us. Okay. Now, let's take a look over here at an example. I got a concrete aggregate. I'm going to call it A. All right. Now, I happen to have 4 string objects, A, B, C, D. Okay. These are my object over here. It's called A, B, C, D. Now, I'm going to create an aggregate. It's called A. Okay. When I create the aggregate, I made the references as such. Put A over here, B over there, C over here, D over there. Okay. And then I'm going to execute my create iterator. So I'm going to create an iterator. I'm going to give it myself. Okay, as we've said over here, where is it? Create iterator gives it itself. To the iterator. Okay, and then now that I have that iterator over here, right, I can do that that for loop. Okay, client code using the iterator operator. Okay, so iterating over the right. So I got the, well, I didn't do a for loop. I did a while. Okay, so I just sprint, get first and then next until I'm done. Okay, just printing what's inside. So when I look at it, what's actually printing is the stuff that's inside the 4 string objects that I had. Okay, now those 4 same string objects, okay, I could have created another aggregate, called it B. I decided to flip it because I want to aggregate, sort of iterate through them in a descending order. Okay, so I go D, C, B, A. Still going to create my own iterator. So this is iterator number 1. This was number 2. Okay, and then put the I over here. I2 dot first, go next. Okay, all the while the 4 original objects not being touched. Okay, I don't actually have to edit those objects myself to let them know what location they are in the array. That's really the most important part. Okay. All right, guys, is this clear for everyone? Before I move on. Say what? Yeah, it's right here. That would be it. This is an example of it. So, you know, I would expect you to create something as such, okay? Like this is the actual products, the actual objects, okay? And this is the iterators of those objects. Okay, okay, good. All right, so we'll move on now to the next design pattern, which is the observer design pattern. I'm correct, yes. Observer design pattern is probably the most interesting design pattern of the groups, okay? The purpose of it is to arrange a set of objects to be affected by a single object, i.e. keep a set of objects up to date with the state of a designated object. Now, the word state here means with the value of it, okay? Because as a variable value, a variable is a state, okay? If I equals 1, that's a state. I equals 2, that's a different state, okay? So I'm gonna move out over here, discard, go back again to the white screen. Where is it? Yeah, there we go. Now the observer design pattern is based on a subscription / notification scheme, okay? So I got an object of interest over here, okay? It has some sort of a value in it, okay? A equals 1, okay? If that A changes, in other words, its state changes from 1 to 2 or 2 to 3, right? This could be of interest to a whole lot of people. So what this object of interest can do is it can have a list of subscribers, much like an email subscription, okay? You get a whole bunch of interested subscribers. They list their names in the subscription list, the mailing list, if you would say, all right? And then anytime some change happens, a delta, okay, it triggers a for loop to go through that list and say, you know, update, 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 same function, update, update, and so on. All right. Really, that's exactly what happens in mailing lists anyway. For example, there's a sale that's happening at a store. Okay. What they have in that subscription list is a whole bunch of emails. Your email, my email, and so on. Okay. When a sale happens, it triggers automatically this notification of the subscribers to happen, and a for loop happens, okay, where it has all the list of the email addresses, and it just keeps saying fire email, fire email, fire email, fire email, and you get that email whether you like it or not, whether you actually like it or not. And if you remember, that actually does follow the MVC approach in the sense that those over here could have been a whole bunch of presentations that are interesting in some sort of a data when it changes. For example, this is A equals 0. A equals, sorry, 1, just say 0. A equals 1, B equals 2, C equals 10. This one over here is showing it as a bar chart. This one is showing it as a pie chart. This one here over here is showing it as a text. Okay, this one is showing it as blue text, so on and so forth. Okay, so if a piece of data changes over here, for example, that C now is equal to 5 instead of 10, okay, all of those are notified, okay? So then when they're notified, the bar changes its view, the pie changes its view, the text changes view, and so on. But what do they actually need in order to realize what actually happened over here? Well, they need also an access to this object over here. Okay, they need an access to the actual source. Okay, and then when they look at the actual source, they dissect it, realize, okay, A was the same as before, B is the same as before. It's only C that's changed. طب خلاص, let me update my view based, or whatever it is that I want to do. It doesn't have to be a view. With the fact that I know that a C has changed from a 10 to a 5. Okay. It could be that one of those over here, for example, this last one, is only interested in A and B. Will it get a notification? Yes, it will get a notification, but it's a needless notification. It's useless. And what it will actually do, it's still going to look at the source object because it doesn't know. All it was told is something happened. You might be interested. Now it's going to look at it and says, well, A hasn't changed. B hasn't changed. Okay, I noticed C has changed, but I don't really care about C to begin with. So honestly, this notification is meaningless for me. This is kind of like similar to you were interested on sales on an iPad, but nonetheless, the sale has happened on televisions. You're going to get the email anyways. You look at the email. So it really happens, right? You look at the email because you're only going to know after you check that email, check the source, and you only realize afterwards that, oh, I've wasted my time checking the flyer and it doesn't have the sale on the thing that I was actually cared about. Okay. Now, source code wise, okay, so I'm going to have a source, a concrete source, and the concrete source is going to be of a type, a general type of an interesting source. Okay. Now, this interesting source, all it does, it holds an array of subscribers. It's going to have a for loop to go through that array. Okay. So once something happens here, okay, it triggers in its parent class, okay, and notify all, so to speak. And the notify all is the one that makes it go through the for loop of subscribers that I have. All right. The source class over here, the other thing it does, it has some admin functions, you know, like add subscriber, remove subscriber, and that's basically really it. That's the two admin things that you have. Okay. What are those subscribers? These are what I like to call observers. Okay. And there could be multiple observers, just like there could be multiple sources. So there's multiple observers. Okay. I got observer 1, I got observer 2, I got observer 3. Okay. But all of them are observers. Okay. And that source has this list of observers. Okay. And then this is going to be O1, O2, O3, O4, and so on. It's in there. And what this is going to do is, as it's going through the for loop, is just going to say update. Something has happened, update, okay? So this over here has a function called update. This over here has a function called update. So over here has a function called update, okay? And as it's going through that for loop, okay, it's going through each one of these and it's just saying update, 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 and so on, okay? Now, when it updates, what does it do? It then grabs a reference to the source, and then it checks what's inside of that source, okay? What changed, what happened, what's interesting, and so on. This guy grabs a reference to it, this guy grabs a reference to it, and so on. And everyone checks for it, all right? As I said before in a previous lecture when we were doing the MVC, this approach has pros and cons, okay? Now, assuming some changes happen to the source, we have 1,000 subscribers. That change is only interesting, sorry, it's actually interesting for 999 subscribers, but one subscriber is not interested. It's not a big deal. We only wasted 0.1% of our efforts, okay? Because the other 999 were really interested. Now, if we reverse it and realize that was only one subscriber that was interested in the other 999, we just upset those people and we bothered them for those for no reason. So a lot of computational power would have been wasted for no reason. If this is the case, you might want to have a direct contact between that source and the one that will be interested in, instead of bothering 999 other subscribers. Okay. But these are two extreme situations anyways. Okay. So if you have 100, 70 of them were interested, 30% not interested. That's okay. That's a good, decent return. All right, going back over here. All right. So again, this follows the MVC. This is my subject at the bottom over here. This is what these views are interested in. Okay. One of them is interested in a tabular form. Other one is a bar. Other one is a pie chart. In case something happens over here, what it does is just says, go to the list of subscribers, let them know that something has happened. So it says saying update, update, update. And then what happens that they come back and say, okay, what actually happened? Then when they see what happened, they go back and they change their own views accordingly. All right, here is my my list. Okay, so this is my concrete source. It has a state. In other words, it has a variable. Okay, and if that variable is changing, that could be of interest to a whole bunch of observers. Okay, it is going to have, we're going to call it of type source, which only gives us a notify function. That notify function, as we're going to see in a moment, is nothing but a big fat for loop, which takes all the observers and it goes through them. And as it goes through them, the observers keeps executing update, 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 update. Okay. The observers are then, each one of them is going to grab a reference to that concrete source and say, hey, I was told there's an update. What's going on? All right. So here's an example. Okay. By the way, this last line over here, this last line that I'm drawing, this is that dotted line that you see at the top. Okay. But it's just happening from the parent classes rather than it's happening from the child classes. Okay. So here I got International Hamburger Company. Okay. So there is a very important piece of information that talks about demand. And depending on the demand changing, some aspect of my organization would be interested. So I got my senior management. They care about the demand changing. Okay, I also got the marketing people. They also care about the demand changing so that they can customize their marketing accordingly. Okay, let's take a look at an example at the source code. Okay, so I got my source. First thing you see, I got my list of observers. Okay, I got an array list of observers. All right. Then this is adds a subscriber, remove a subscriber, and then here it's just commented out. But here's my for loop that reads through the list of observers. Okay. One thing you might notice. Okay, this one says abstract because ultimately the source by itself is not of interest. Okay, it's only when we have the concrete source. Okay, so we got concrete source, it extends source. Going back again over here, you'll notice that these ones over there are not abstract. The reason is they will be inherited as is. You don't need to be modified. Okay, the concrete source, it's not going to be doing any of this admin stuff itself. Okay, leaves it up to the parent class to handle it. I don't need to change it every time I have a different concrete source. Okay, it's really the same exact code that gets repeated over and over again. So I don't have to have it as abstract to be implemented in a specific way by the child class. Okay, so this guy over here, concrete, it actually inherits next. No, was it not next? Sorry. What were they called? Attach, detach, and notify. As is. Okay. In addition, of course, to whatever it is that it wants to do. And all it does, it grabs sorry. It has a function called get state and returns its current state. It has a setter, it has a getter. Okay, so if I ask for the state, it tells me what it is. If I set it, it sets its own state to it. And what is the state? It's nothing but a string variable. Okay, so this is my source, and this is my concrete source. Now we got the observers. Okay, so I got the class called observer. All it's saying, for all my child observers, you have to have a function called update, because this is the only way I'm going to reach you. Okay, because when the source goes through the list of observers and keeps asking for execute function update, we got to agree on one function name. Okay, I happen to call it update. Okay, all right, and you see this class called observer. Okay, this was the type that was in my array list in the class source. Okay, so it has an array list of observer objects. All right, here's a concrete observer. We got one. Okay, it has its own name. All right, and an observed state and a concrete state. It has a whole bunch of variables. All right, now here's the interesting part. When I'm creating it, I'm creating a reference to the concrete object. Okay, so if we go back over here, this is actually my concrete observer, and I'm getting a reference to the concrete object. Because what good does it tell me, does it do me, if I tell this guy, go ahead and update, and then it can't actually get a hold of the actual source object. Okay, it needs to get a hold of the source object. Okay, and this is why this exists. Okay, in case it does get an update function invocation, okay, it grabs its source, which was this over here. Okay, this is the source. It grabs it and says, please let me know what is your current state. And that's it. Okay, and then it just prints it. Right? After it printed, it can also, what it can do, it can set on the source any state it wants. Okay, so here I am. I got a concrete source. Okay, it's called S. Right, I'm going to attach to it 3 observers. One is called X, one is called Y, one is called Z. And then I'm going to say that my variable, which is called state, I want to set it to A, B, C. Okay, and then go ahead, let everybody notify, and then let everybody execute the update on it. Update, update, update. And when they do, when they execute the update, they print their state. So then each one of those will print, say, I'm observer number X, this is my state. I'm observer Y, this is my state. I'm observer Z, and this is my state. All right. In its simplest form, this is the simplest observer design pattern. This is a situation where we have just the one source and the one observer. Obviously, you can see how this can scale up to more sources and more observers if I really, really want to. Okay, so I can have an observer observing multiple sources, and I can have a source being observed by multiple observers. Okay, is this clear for everyone, guys? Okay, so in the next lecture, we're going to be doing the state and the, what's the last one? Chain of responsibility design patterns. And with that, we would have finished the design patterns part of the course. Any questions, guys, about this chapter before? Any questions? Let's see. Doctor, is the exam going to have questions other than the exercises questions? Well, I'm not sure I understand the question. It does have, I mean, is it memorization, true or false, and multiple choice? No, I don't. This tends to be not to be type of my exams, but maybe some of those will pop up in the final exam. But I like to bring problem solving questions. Well, yeah, I mean, problem. I don't like to say word diagrams. I just like to say problem solving questions. Okay. The type of problems that we actually solve is to create diagrams. But doctor, can you please upload an answer key to quiz 3, 4, 5, and 6? We'll see about that. Okay, let me consider it. Can you tell us what type are we expecting? You mean what type of design patterns you mean, Hisham? Oh, I think I just answered that. So yeah, problem solving questions, just like you had in the quizzes. All right. I don't expect I'm gonna bring any multiple choice or true or false questions in a midterm. See what? Yeah, so that's a problem solving one that didn't actually require neither memorization, neither drawing anything per se. Okay, but you know, that's really a one-off question. This one is no short answers. I don't think you guys took this is 1.5 course with me, right? I never bring you any short answer questions. Well, except for client server one, right? Where they I need to understand your rationale behind your selection. But other than that, that's probably the only exception that I have in my all of my courses that I teach that I ask for a short answer. All right, other questions, guys? I agree with the 3-4. The 5-6 we just have the answer. But for the quizzes 3 and 4, we still don't know the answer. Right. Yeah, no, the whole point is that you actually come and see me for those questions, right? Rather than just waiting until the end, but we'll see what we'll do, okay? Anyway, any other questions other than the key solution thing? Now there's probably going to be another 2 more. Okay, and again, to prep you up for the final. Okay, it's for your advantage, really. Okay, and the other reason why quizzes are high is because I'm not in this course offering giving assignments. Okay, so if somebody says, "Oh, well, we're getting too many quizzes," well, that's because you're not actually getting any assignment. That's number one. And then what I actually do is instead of bringing like 2 questions in one quiz, I just split it down to 2 quizzes. So each quiz is just 1 question. So if you really think about it, it's kind of like I would give you 4 quizzes. Each one of them is it's got 2 questions. So, you know, we're just playing around with numbers. All right. Okay. Any questions? Any further questions? How many problems? We'll study and you'll know. No, not I mean the types. I mean how many like are we gonna do like a few problems? That's for me to know, for you to find out. See, your job is to study and understand. My job to formulate the questions. And if you do study and you understand, it shouldn't bother you what type of question you're actually getting, or how many. Okay. Okay, guys at home, any further questions? Okay, so that's it for today. Best of luck on Wednesday, inshallah. Take care, everybody.